So let's look at this next section, the slope of a line. Here's what I want you to understand. I'm going to try to relate slope to something real life. So have you ever taken a trip where you're climbing a really steep hill, or even going down the other side of a really steep hill, either in your car or you're riding your bicycle, whatever, right? Motorcycle, whatever. Steep hill going up or a steep hill going down. Well, the steepness of that hill is considered the slope. How steep is the hill that we're going up? Or how steep is the hill we're going down? Or if you're on flat land, is there even a steepness to consider? Are you with me? Okay, that's basically slope. How steep is the hill you're driving on? Cool? Okay, so now let's look at the mathematical definition to finding the slope of a line. Okay, so a line is vertical, or it could be horizontal, or it could be a slant. So, finding the slope of a line between 2 points, x sub 1, comma y sub 1, and x sub 2, comma y sub 2 is given by. So m now stands for slope. Anytime you see the m in a linear equation, that stands for slope. And how I find it is the difference of the y's over the difference of the x's. Now here's the deal. Most of us have learned to find slope by doing y sub 2 minus y sub 1 over x sub 2 minus x sub 1. But to be honest with you, it doesn't matter if the order is reversed. What matters is you subtract the numerator and denominator in the same order. So on this one I have y sub 1 minus y sub 2, which means on the bottom I have x sub 1 minus x sub 2. Got it? Okay, now some of you are going, what's this sub 1 and sub 2 stuff? When you see these little subscripts, that tells me that's the first x, that's the first y, the second x, and the second y. Cool? That's all it means. First x, first y, second x, second y. Good? Okay, so let's look at a couple of examples. They're asking us to find the slope here. So, the slope formula says m equals. So, I'm supposed to subtract the y's. And it doesn't matter which order I subtract them. I just have to make sure I do the denominator in the same order. So, I'm just going to do negative 6 minus negative 4, because this was y1 and this is y2, so I decided to subtract in that order. Cool? Which means in the denominator, I better make certain and take the negative 2 first for the x's, because I took its y value first in the numerator. So the negative 2 minus 4, because this is x sub 1 and this is x sub 2. Are we good? Okay, so let's do our work. Yeah, that double negative makes that a positive, right? So I'm actually doing negative 6 plus 4 in the numerator. What do we get? Good, we get a negative 2. And in the denominator, I have negative 2 minus 4. Good, negative 6. Can I reduce it? Because it is a fraction. Good, it's going to be a positive fraction, and it's going to be a positive 1/3. So in this particular case, I'm going to erase this guy for a second. We have our slope, we have m equaling 1/3. Cool? I'll explain to you what that means in a little bit, I promise, so hang in there. Let's look at the second one. M equals, right? I'm going to do this y first, so y minus 8 over, which means I have to do this x first, 3 minus 1, correct? Okay, so 1 minus 8, yeah, that's a negative 7. 3 minus 1, yep, that's a positive 2. So in this case, my slope is equal to a negative 7 over 2. Cool? Okay, so hang in there. I got some more examples for us. All right, so let's look at this third example. Still asking me to find the slope. So, m equals, right? We have to do the difference of the y's. So I'm going to take this first y value, 5 minus the other y, which is 5, over, and now I'm going to have to take the negative 2 first, since I took its y first, minus 3. Good? Okay, which means I am going to get 0 over negative 5. So what's 0 divided by negative 5? All right, so I'm hearing some of you say 0, but then I'm hearing some of you say undefined. And some of you aren't sure which one this is. So let me sidetrack you a second, shall I? Shall we? Okay, so this is a division problem, correct? The numerator is always underneath, and the denominator is always on the outside. You're like, that 5 is negative. I get it. I don't really care about the negative at this point. So the numerator is always underneath, and the denominator is always on the outside. So you're trying to find how many times 5 goes into 0, right? Well, sometimes a better question to ask ourselves is this. What can I put on top that when I multiply by 5 gives me 0? What number can you put on top that when you multiply by 5 gives you 0? Yeah, 0. This question mark would be a 0 because 0 times 5 is 0, isn't it? Which means in this case, m is equal to 0. Cool? Good. Let's look at this other one. M equals, right? So I'm going to take the negative 4 first, minus the 3. And that means I have to take this x first. So 1 minus 1, which gives me, good, negative 7 over 0. And you're like, oh man, what's that one? Sidetrack. What goes underneath? Yeah, the numerator. And I know it's negative. I don't really care about the negative right now. And so the denominator's on the outside, right? So remember the question. What can I put on top that when I multiply by 0 will give me 7? Yeah, that's kind of a crazy question, right? Because anything times 0 is 0, isn't it? Anything times 0 is 0. So can I put anything on top to multiply by 0 to give me 7? No, this one's crazy. This is a crazy question to ask us, which means this. Your slope in this case is undefined. Cool? Good. So those of you who have been confused about this in the past, when m equals 0, right? Or m equals, pardon me, when you have 0 over a number, that answer is 0. When the 0 is on the denominator, that answer is undefined. Cool? Okay, so now, I'm going to sidetrack us a second. I would like to graph these last two problems that we worked on. Okay? I would like to graph them. Excuse me. So, the first problem, we end up with a slope of 1/3, didn't we? Okay. And the points that we had for that particular problem were -2, -6, and +4, -4. And the second problem, we ended up with a slope of -7, and we had the points 3, 1, pardon me, that's -7 over 2, 3, 1, and then 1, 8. Correct? Okay, so here's what I'd like to do. I want to take a look at this first one, and I'd like to plot these 2 points. So we have -2, right? And then -6. And this one, second point, was a +4 and a -4. All right. So this is the graph on number 1. Do you notice that this is an uphill line? We always read from left to right because we read from the smallest x's to the largest x's. When I graph the first one, I have an uphill line, don't I? I'm driving uphill, right? Good. Hold on. Let's look at number 2. Number 2, I'm going to plot the points. So the first one is 3, 1. The second one is 1 and then 8. And when I connect these 2 dots, this is number 2's graph, I get a downhill line, don't I? Do you agree? This line goes downhill. which means this. Notice the first one, we had an uphill line. I know my slope was a fraction, but more importantly, this was a positive. And this positive number gave me an uphill line. Number 2, this slope was negative, which means it gave me a downhill line. Cool? Okay, so positive slopes will give you an uphill line. Negative slopes will give you a downhill line. Yes? Okay, let's look at number 3 over here. Number 3, I'm going to plot these 2 points. So we have -2 and then 5. And we have 3 and 5. And when I plot those 2 points for number 3, do you notice I have a horizontal line? Yeah, it's a flat line, isn't it? It's kind of like there are 0 hills to be found, right? My slope is 0. I got 0 hills to be found. It's a flat line, flat land. Cool? Okay. And then let's go graph number 4 over here. My first point was 1 and -4. My second point was 1 and 3. And when I connect these 2 for number 4, I get a vertical line, don't I? Here's the fun I like to have with this. This is you trying to drive up the side of a building. And I don't care how good of a Hummer you have, and to me, the only one worth its grain in salt is the H1, right? You can't drive up the side of a building. By the way, you know when Batman drives up the side of a building, they actually turn the camera sideways on him? Yeah, sorry to burst the bubble, but you can't drive up the side of a building. That's crazy. That's undefined. It makes no sense. You trying to drive up the side of a building. Good? Okay, so you only get 4 slopes. A positive slope, which means you're going uphill. A negative slope, which means you're going downhill. A 0 slope, which means you're driving on prairie land out in the middle of nowhere. 0 hills to be found. And then an undefined slope, which means you're trying to drive up this side of a building. That's totally crazy. That ain't happening. Cool? Good. Hang in there. I'll be right back with some more examples. Okay, so let's look at this 5th example. Still asking us to find slope. So, remember, slope is the y's over the x's, right? The difference of the y's over the difference of the x's. Well, do you notice in this case they didn't give me any points? In actuality, they gave me a picture of a house. And they're looking at this roof. And here's the question. They want to know what is the pitch of the roof. And by the way, that's a real life problem. When they're building homes, they're like, okay, well, what's going to be the pitch of the roof? Regardless what they call it, the pitch of the roof is still the slope. With me? Okay, so remember, the y's are on top, and the y's are vertical, aren't they? Well, the 8 is the vertical line here, which means I'm going to put 8 feet on the top. And on the bottom, I put the x's, which go left and right. They go horizontal, which is that 12 feet. With me? Okay, so here's the thing. I have a fraction. Let's reduce it. We can reduce it to 2/3. Correct? Now, let's interpret this, because you're like, okay, well, what does that tell me? This is what that tells me. Remember, these are both in feet. So what this tells me is for every 2 feet that they go up, they are going to go 3 feet out to the right. They go up 2, out 3, up 2, out 3, up 2, out 3. That gives them the pitch of this roof. With me? Cool. Let's look at this one. So I got this truck driving up a hill. Clearly he's driving up a hill, right? And they're asking me to find the grade of the hill. So, regardless what they call it, the grade is still slope. And I do the y's over the x's. Well, the y's, right, is 15 feet over the x's, which in this case would be 100 feet. Cool? And I can reduce this, but in this case, I'm going to ask us to change it to a percentage. And 15 over 100 reduces to this decimal, which as a percentage is 15%, right? Okay, so if you've ever driven up one of those very steep hills, on the side of the road they have this sign that says the grade of the hill. If the grade of the hill was 15%, here's what that means. That means 15 over 100, which means for every 15 feet they go up, they have to go across 100 feet. That's how they get the rise of this hill. Or I could say for every 100 feet they go across, they go 15 feet up to make the hill. For every 100 feet they go across, they have to go up another 15 feet to create this hill. Because remember, they're putting the man-made roads on the hill. So again, for every 100 feet across, they go 15 feet up. Another 100 feet across, they'll go another 15 feet up, and they'll keep going that way, and that's how they get the steepness or the grade of the hill. Cool? Yeah, these are two really nice examples because they're everyday life examples. Hang in there. I'll be right back with some more. Okay, so let's look at these directions. They want to know which line has the greater slope. So let's take a look at example number 1 over here. Line 1 has an uphill climb, doesn't it? Line 2 has a downhill climb, or descent, I should say. Agreed? Okay, so let's look at line 1. Since line 1 is going uphill, that means its slope is what sign? Yeah, that means its slope is positive. Line 2 is going downhill, isn't it? So if it's a downhill line, that means its slope is, good, negative. So which line has the greater slope? Good. Line 1, the slope of it is greater than the slope for line 2. Because a positive slope is greater than a negative slope. Got it? You're like, is that easy? It's that easy. Don't read too much into it. Got it? Okay. Let's look at problem number 2. Line 1 has this downhill. Line 2 is this horizontal. So, line 1, that's going downhill, isn't it? So a downhill line has what kind of slope? Yeah, it has a negative slope. Line 2 is horizontal. What kind of slope or horizontal lines have what kind of slope? Remember example number 3 we did before? Yeah, that's got a 0 slope, doesn't it? That's a 0 slope. So which one is greater, a negative or 0? 0 is greater than negative numbers, right? So in this case, line 2, I should say the slope of line 2 is greater than the slope of line 1 because 0 is greater than any negative number. Cool? Okay, hang in there. I'll be right back. All right, so let's scoot on to this thing known as the slope y-intercept form. Some of you may recognize this. That form is y equals mx plus b. Yay! This is what's officially called slope y-intercept. Now the reason it's titled slope y-intercept is because this form gives you the slope and the y-intercept. But here's a major note to self. The only way it gives you the slope and the y-intercept correctly is when the y is by itself. Yeah, huge note to yourself. Write it down in your notes. The only time you find the correct slope and the correct y-intercept is when the y is by itself. So, as we've already discussed, when the y is by itself, m is always representing the slope. So, m is multiplied by the x. M is the coefficient of x. Are you with me? Good. Now, to find the y-intercept, here's something you have to remember, kind of a blast from the past. The y-intercept, the way you find it is you always let your x equal 0. So if x is equal to 0, what's m times 0? Good, 0. So 0 plus b is b, which means y must equal to b. So this is how you find your y-intercept. Cool? Okay, let's look at a couple of examples while we're here. So here's a linear equation, right? And it's linear because the power on x and power on y are both 1s, so it's linear. And I would like you to find me the slope and the y-intercept. So what do you have to make certain of first? Good. You have to make certain that the y is by itself. Is it? Yes, it is. Which means, can you now find the slope and the y-intercept correctly? Awesome. So in this particular case, what would be your slope? Yeah, your slope would be a -2. That's the coefficient of x. Good? And your y-intercept. Remember, to find it correctly, you always allow x to equal 0. So, plug in 0 for x. What's -2 times 0? 0 plus 1? 1. So y must be equal to 1. Good? Awesome. Got another one for us. Okay. Still wanting to find the slope, still wanting to find the y-intercept. What do I have to make certain of first? Yeah, I got to make certain the y is by itself. Is the y by itself? Nope, it certainly isn't. So first things first, let's get the y by itself, which means the first thing we need to do, yeah, get the 4x to the other side, right? So we're going to minus 4x from both sides, which means my next line looks like 5y equaling 20 minus 4x. And then what? Good, divide everything by 5. And we get y equals 4 minus 4 over 5x. Right? Okay. Now can you identify your slope and your y-intercept correctly? I certainly can, because the y is by itself. So in this particular case, m would be equal to, yeah, it's the coefficient of x, which in this case is a -4 over 5. I don't care if they've written the x first or the x second. With me? Okay. And your y-intercept. Good. X must be equal to 0. So -4/5 times 0 is 0. 4 plus 0 is 4, which means y equals 4. Cool? Does this make sense? So if the y is by itself, that's easy peasy, right? I identify the coefficient of x for my slope, and then I'm able to plug in 0 for the x and get the answer for y. But if it's not by itself, you're going to have to do some rearranging to get the y by itself. Which is why in a previous lecture we went through those examples of solving formulas for various variables, because they help us here. That whole exercise helps us here getting the y by itself. Okay, now with this information we can actually graph. Cool? Okay, so hang in there. I'm going to be right back. I need to clear my board, and then I'll be right back and we're going to graph. Okay, so let's go graph those two problems we just found the slope and the y-intercept for. So here was the information for the first one. We found the slope of -2 and the y-intercept of 0, 1. And we know it's supposed to be a line, correct? So how many points make a line? Good, 2. How many points do I have? Yeah, just 1. So I'm at least going to plot that 1 point that I've been given. And that point is 0, 1. Right there. Now, I need a second point, don't I? Okay, here's what I'd like you to think of. I'd like you to think of slope as a set of directions to get me to the next point. Slope, from what we learned a few moments ago, is a formula. It's the y's over the x's, correct? Well, my slope here is -2, but slope is usually a fraction. And so how do I make -2 into a fraction? Good, -2 over 1. And by the formula that we learned, the numerator is the y's, right? Represents the y variable, and the denominator represents the x's, doesn't it? Okay, so according to these directions, in the y direction, the negative on the y's, is that going up or is that going down? That's going down. So according to the numerator, in the y direction, I'm going to go down 2 spaces. So from the point I already know, I'm going to go down 2 spaces. The denominator represents the x's. The x's go left and right. And since this is a positive number, good, go to the right. How many? 1. So these set of directions from the y-intercept, the only point I've got, tells me to go down 2 spaces, go right 1, and that's where I'm going to find my second point. I could do it again if I wanted to. From this point, I go down 2 spaces and right 1, and I can even find a third point. Cool? And then I can connect the dots, and I find the line that goes with this equation. By the way, my slope was negative, wasn't it? And I got a downhill line, don't I? Awesome. Cool? Okay, let's go look at the second one over here. So, again, I know it was a linear equation, right? Because both x and y had powers of 1, so I know it's linear, so I need a line. And I need how many points? 2. How many do I have right now? Just that one. So that's the point 0, 4. Got it. And I have this slope. Well, this slope's already a fraction, isn't it? And the numerator represents the y's and the denominator represents the x's. Agreed? Okay, so according to these directions, from the point I already know, from my y-intercept, the top number says to go which direction? Good, down, because since it represents the y's, I either go up or I go down. And the y's, or the negative direction on the y's, is down. So from that point, I'm going to go 1, 2, 3, 4 down, and then, good, since this is a positive, I'm going to go right 5 spaces for the x's. And here is point number 2. And when I graph it, that will be the graph of my equation 4x plus 5y equaling 20. And yes, another downhill line because my slope was negative. Cool? Okay, got a couple more examples. I'll be right. Okay, so let's look at problem number 3. We want to graph it, but I also want us to find the slope in the y-intercept. Got it? Okay, so in problem number 3, do you see an x? Neither do I. So since there are no x's, what do you think that coefficient of x is? Yeah, that coefficient would be a 0. So in actuality, if I really wanted to, I could rewrite this as y equals 0x plus 4, because that would basically be the same thing, wouldn't it? Good, which means my slope here is what? 0, and my y-intercept? Yeah, x is 0, which means when I plug it in, I get 4 for the y. Cool? All right, let's graph this. When I graph it, I need 2 points, and 1 point has been given to me, and that's the point 0, 4. So I'm going to plot the point 0, 4, and there it is. And by the way, slope is always what kind of number? Good, a fraction, which means technically this could be written as 0 over 1, couldn't it? And the numerator is your y variable, and the denominator is your x variable. So technically, according to that slope, I don't go up or down at all, right? I stay here. And since this is a positive one, good, one to the right, which means don't go up or down, just go one to the right. Don't go up or down, just go one to the right, which means I get a horizontal line, don't I? Passing through which axis? The y-axis. Through what number on the y-axis? 4. Isn't this how we have graphed this equation in the past? This equation in the past, when we have graphed it in another lecture, said go only through the y-axis and pass through it at the number 4, which is what we have, right? By the way, a zero slope means I've got like prairie land, right? 0 hills that I'm driving on. That's my graph. Good? Okay, let's look at this one. Now this one is a little bit different in terms of finding a slope and a y-intercept. This one, my recommendation is you graph that one right away. Graph it, because that one's very different. Trust me. Because you're like, well, I don't even see a y. Yeah, I don't even see a y either for a y-intercept. By the way, we know how to graph this line. This is a line passing through which axis? Yeah, it passes through the x-axis only, because there's only the x variable, right? Mentioned that in a previous lecture. And it passes through this x-axis through the number -2. So you end up with this vertical line, don't you? This is a line passing through the x-axis only through the number -2. Cool? Okay, so help me out then. What's the slope of this vertical line? Yeah, this one's undefined. This is you trying to drive up the side of a building. This is crazy. This doesn't make any sense whatsoever, does it? What about the y-intercept? Where does this line cross through the y-axis? You're like, it doesn't. You're right, it doesn't. So if it's not crossing through the y-axis, does it have a y-intercept? Nope. In this case, if they ask for the y-intercept, we're going to say none. Cool? Okay, so especially these last 4 examples, you might want to rewind them. Rewind the video, replay these to make certain you understand how to graph using the slope and the y-intercept. Okay, you guys have fun with this stuff. I'll catch you on the flip side.